I have taken a numerical problem from this book published by JK Education Center, and the name of the book is Enjoy Science. And this numerical problem I am going to solve here for you. And look at this problem. Radius of Mars, one of the planet, is 2440 kilometer. If it were made of iron of relative density 7.8, what would be the value of G on its surface? Now, look at this. It can be represented diagrammatically this way also. Let's say this is the planet Mars, and this is its radius, which can be denoted by R. And we have to calculate the acceleration due to gravity on its surface, which can be represented by G. And we are going to calculate this. But the given is radius of the Mars and the density of this planet, but not the real density. What is taken actually, if we consider that it is made up of iron of density 7.8, then what will be the value of G is the question. So we can solve this way. We can solve this numerical this way. Radius is equal to 2440 kilometer, and we are using SI system, that's why kilometer doesn't work. I'm converting it into meter, multiplying by 1000, and it converts to meter, and this is equal to 2440,000 meter. And we are using short notation for this. 2.44 into point is shifted from this place to this place. That's why it is going back 6 digit. That's why 1 2 3 4 5 6. So I am writing 10 to the power 6 meter here. This is radius. Now relative density is given. Relative density is equal to 7.8. We are later converting it into density in SI system. G is the question. Now what we know, relative density is equal to density of substance, density of the substance, which can be denoted by D, symbol D, density of the substance upon density of water. Water at 4 degrees Celsius. Relative density, I am going to convert relative density into normal density in SI system. That's why this equation is taken. Relative density is given. It is how much? 7.8. That's why I am writing 7.8, and this is equal to this density of this planet is, let's say, D, and density of water at 4 degrees Celsius, we know its value 1000 kg per meter cube. Now 7.8 multiplied by 1000 gives the density of the assumed density of the Mars. This is equal to 7800 kg per meter cube. Now after this, let's go through this acceleration due to gravity. Now the equation what we are using, we have an equation. This equation is G equal to capital G capital M by R square. This equation can be used to get the result, but mass of this mass is missing, so it must be somewhat different than M, but we can put this way: G equal to capital G. In place of mass, I can write density into volume, because we know that mass is equal to density into volume. Density equal to mass by volume, that's why mass equal to density into volume. And in denominator we have radius square of the radius. But volume of this planet is also missing. Since volume is missing, so we can consider the volume as a sphere. We can consider the volume of this mass as a sphere. Then we can write G equal to capital G into D into, if it is considered as a sphere, then 4 by 3 pi r cube. Because sphere, its equation is V equal to 4 by 3 pi r cube. That's why in place of V I am writing this, and here we have r square. R square, and this r, one of the r is left, q is cancelled. Now everything we have, we can put all these value. This is equal to, G is 6.67 into 10 to the power minus 11 into D is 7800, and 4 by 3 remains same, and pi 22 by 7, and radius multiplied by, radius is 2.44 into 10 to the power 6. Now next step will be 6.67 multiplied by 7800 multiplied by 4, again multiplied by 22, again multiplied by 2.44 gives 111,022.72. If we use calculator, we can get this value into 10 to the power 11 minus 11 is left, into 10 to the power 6 is left. Now what we have in denominator, 3 7s are 21. If we divide this number with 21, 7 3s are 21, sorry. If we divide this with 21, then what we get? We'll get 5.31953.46. But if we divide this by 21, we'll get this. This multiplied by 10 to the power 5. And we have here 10 to the power minus 11 and 6 also. If this is divided by 21, we'll get this into 10 to the power 5. We have 10 to the power minus 11 also. The same base, that's why I'm taking this as power. And 10 to the power 6 plus 6. Now minus 11 and plus 11 makes it 0. That's why this is equal to 5.3195346 into 10 to the power 0. 10 to the power 0 means 1. 1 multiplied by this remains same. That's why 5.3, instead of writing many digits after decimal, I can put 2, and therefore G is equal to 5.32 meter per second square. This way we can solve this numerical, and lastly we got the value 5.32 meter per second square.